today we'll discuss about the torque slip characteristics of three-phase induction motor. This is a very important question from your exam point of view. Okay, in this we are on the x-axis will take slip or speed, or on the y-axis will take torque. This is for the positive side and this one is for the negative side. Okay, so in the starting, if we increase the value of slip or speed, then in that case torque increases. Okay, like that. Now obviously it will increase up to a certain limit. Then after that, if we'll increase the speed, then torque starts decreasing and continues to decreasing. And again after a certain period of time, if we'll increase the speed, then torque it will be constant. Like I'm giving you one example of the car which you drive. Okay, in starting, when you start the car, you press accelerator, right? You press accelerator means you are providing speed to the car, right? If you're increasing the speed of the car, then in that case your wheel starts rotating and your speed is increasing, means the torque is increasing, correct? Like you more press the accelerator, more speed will be there, more force will be there on the wheels. Rotational force is known as torque, means you are driving a wheel, so more force you will apply, then more fast it will move. Okay, again you press the accelerator, the torque will increase and your speed will increase. Clear up to here? Okay, so it will increase up to a certain limit. Now it will increase up to a certain limit, like again you are pressing the accelerator, your speed of torque will increase. So that comes under the stable region. That comes under the stable region, means it is a stable condition, because you are driving a car, you press the accelerator and your torque is increasing. But what happen if you continuously increasing the speed, okay, of the car? Then what will happen? The wheels of the the wheels of the car will start decreasing the speed, right? Like in the starting you are pressing the accelerator, car speed increases, okay, torque increases, but up to a certain limit it is increasing now. Again you are pressing the accelerator, again you are pressing the increasing the speed, then the torque starts decreasing, your car speed will starts decreasing, correct? That comes under stable region or unstable region? Tell me. That comes under obviously unstable region. In the starting condition you increase the accelerator and car starts rotating, torque is increasing. Then again you are increasing the speed, then torque starts decreasing, that is comes under unstable region. Again after that unstable region you are increasing the speed, you are continuously increasing the speed, then what will happen? After certain time your car will stop, or it will decrease its torque, right, up to a certain level. Clear this thing? So this is the function of the motor, means in this case your induction motor will work like a motor. So in this case I told you ns is greater than nr. When ns is greater than nr, then in that case it will work as a motor. Clear? This is a stable region up to here. After that we are having unstable region, and after that when we again increasing the speed, then your car will stop, right? So that comes under braking. Braking means your car stops. Maybe that could be a lead to the accident, because again you are increasing the speed, then suddenly your car stops at some point. So that is known as braking, or we can say that counter current braking. Okay, another name of counter current braking or braking is where another name is plugging. So plugging and braking are both the same things. Clear this thing? Now this is for motor. If we'll draw the same graph on the negative side, first speed is increasing, then torque is decreasing. Like first torque is increasing on the negative side, then torque is decreasing on the negative side. Here in this case nr is greater than ns, and if rotor speed is greater than stator speed, then it will work as a generator. Okay, this is for torque, this is for speed. If NR is greater than NS, then it will work as a generator. If NS is greater than NR, it will work as a motor. For the same graph, we'll draw it for the generator in a same graph. Understood?